All right, the broadcast is
Right.
live.
Hey, everyone, and welcome to our first Crystallize live stream of 2022. Hope everyone is having a great start to the year so far. I'm Brendan, host of today's live stream and an engineer here on Crystallize's developer experience team. And today I'm joined by Alex, a senior front-end developer here at Crystallize as well. How are you doing today, Alex?
I'm doing great. It's 9 a.m. over here in San Diego, and I'm just enjoying the
Perfect.
start of the day.
Perfect. That's great. And one thing that we're very passionate about here at Crystallize is, of course, performance, especially the way that it affects both the experience for the end user and whether they want to come back and interact with your website again. And also, SEO is a big important thing to us at Crystallize as well, and that sort of goes hand in hand with performance as to how your website gets ranked in the search results. But today we'll be talking about web rendering, which is essentially a bunch of different methods and technologies that we can use to render the content of our website. But each of these things have their fair share of pros and cons. They work in particular situations really well, and perhaps are not so suited to others. And like Alex, I've heard the terms like client-side rendering, SSR, server-side rendering, those hydration, pre-rendering, these sorts of terms thrown around. But perhaps you could explain to us exactly what these sort of concepts mean and how they sort of compare with each other, and perhaps where you'd use one over another.
Yeah, totally. I mean, that's the main topic that out of for this live stream to be about, and that's what the rendering on the web article on Crystallize aim to explain. So I prepared a little bit of kind of a take you through time, like in the history of web development and how things work in the past and how things are going now. And afterwards, I have like a small demo using some React technologies that we use at Crystallize, including Next.js, Remix, and client-side Create React app. So we can get into the demos afterwards. But yeah, why don't we go over to Excalibur, and then we can kind of get started.
Yeah, sounds good.
Ready?
Yeah.
Okay. So yeah, I think I have something prepared. So basically, let's just go back to basics and talk about what is a website. Um, so at its core, a website is basically like a document of like HTML, CSS, and JavaScript, right? So every time you visit a website like Excalibur here or Crystallize.com or Google.com, everything is like these everything made up of these three files. So let's think about what happens when your browser, every time you use Chrome or Safari or whatever, to visit like a website onto the internet. Um, So every time you visit a site, what's happening under the hood is it's going through. Okay, so basically, it's basically going to the internet, and there's a thing called DNS, which is like domain name, something, where it kind of look at okay, so you're looking for Google.com. It's basically this IP address, which is like this computer. So what happened is there's a computer that will take in your request and then responsible for telling you what the HTML, CSS, and JavaScript is for that domain, or JSON if it's an API, right? Yeah, but so back, let's just say 20 years, a long time ago. Um, the web started as a way for scientists to communicate with each other. So mainly the content of everything was just static with HTML, CSS, and like back then there wasn't even JavaScript, right?
So it was just basically you made a request to the server and it just gave you back these files. And
Exactly. And yeah, so like when you make a request, so there needs to be like some server to respond to it, and then it would transmit like the bytes of the HTML and CSS files back to your own computer, and then the browser would then decode those bytes and render the website as you see it.
yeah.
So you know with the server, so basically you need to have like a physical computer located somewhere to take in all of these responses. So for example, I know you are currently in Norway, right? And let's say that I have my computer acting as my server. So every time you visit one of my websites, what happened is you have to like your computer have to make a signal all the way to my computer in San Diego before it can get its way back to where you are. And then with something like WordPress or PHP, what usually happens is there's another component to the stack, which is basically like a database, so that the server would then talk to the database to fetch some dynamic data, and then use a template engine. So basically, you can use PHP or Node.js or Python or whichever technologies you want.
Yeah, your
You would
classic
then
sort of
fetch
language.
data from database and run data through template engine, right? So there's some sort of template engine that takes in the data from the database and turn it into HTML and CSS and JavaScript. And then this HTML, CSS, and JavaScript will then get delivered back to the browser. So
this process that you're doing here, whenever you make this request in this classic sort of flow, it's like as soon as you make the request to the server, it's running through all these series of actions every single time you request it, right? So it has to do the same sort of work every single time it gets that new request. There's not really anything involved that sort of cuts down what has to happen if you're like refreshing the page and just wanting some updated content,
yes,
like a small part of it, for example.
Yes, exactly. So there's some some technologies or some patterns you can do to optimize that flow. But traditionally, for example, if you think of something like WordPress, this is how it works. Every time you go to the server, it will then talk to like the MySQL database to fetch what the content of that page is, and then return back. So this is traditional server-side rendering. And so let's just say what happens if you only have like a static site. Like let's say you have a block of 10 posts, or if you have like a portfolio of one single page, right? So when that happens, usually you don't really need to do this step. You don't need to fetch the data from the database because it's so simple. You can just write the HTML CSS yourself. So you don't. So potentially, what you can do is you can write your own HTML CSS, and have your server serve this and bypass this whole fetching data from the database. And if you can cut that part out of your stack, like if you can cut the talking to the database, then the server will be a little bit faster to respond. But so this is what you want to do, if you have like a static content, if you have like a small number of pages. But the problem with this is, if you're in Norway, you still have to go all the way to the US to visit my website if this is how I decide to host it.
Exactly, and there's a lot of latency involved in that.
Yeah, exactly. And I mean, it's we're just talking, Norway to the US. Imagine if you're in, India, you're talking to the US, it's going to be like very different.
Yeah.
So one cool technologies that people come up with to solve this sort of things is if you just basically have like static content like this, you can use something called the CDN, which is short for like content delivery network. So what that means is instead of having one single server in one location, let's just say in San Diego, California in US, right? Like instead of just having this in this one physical computer, what I can do is I can upload my site to the CDN, which basically means I would just send the exact same file here to another computer, let's say in London, UK, or I can send it even to Norway if there's a like if it's part of like this the CDN network, or Tokyo, Japan, or whatever, right? So all of this will make up the CDN network. So if I say that my websites live in this CDN, and I need to like configure that with a CDN, then every time the browser needs to visit my website, it will go to the CDN, which internally have like a routing system so that they can serve my HTML, CSS, and JavaScript correctly.
Yeah,
And
so
doing
you're
that,
getting
we
back
can
from
cut down.
you're getting it back from a closer location, essentially, which cuts down on that latency for these larger sort of files.
Yep, exactly. So this is like where the CDN comes in, and so that if you only have static content, then it gets a lot easier to host it and deploy it globally because you can leverage the CDN. So with this, like from this technologies, people started building tools called like static site generators. So imagine technologies like Jekyll or Hugo. So these are kind of like the OG, static site generator. But I bet like there's a bunch of other versions where people kind of like hand roll them. So what this mean what a static site generator does is imagine there's just like a local computer, right? Just imagine there's a computer. Every time you finish, have your site ready, what you can do is it will then talk to like a database or like a data source somewhere. So it would then talk to the data source to fetch data from DB. And then the logic is kind of like, let's say it fetch or block articles from the website. So imagine you have like an articles array, right? So the logic would basically be article loop. So for article for each article in article, you will then run it through template engine and generate a HTML and JavaScript and CSS file combo for that page, right? So this local computer results, it will give you a bunch of HTML, CSS, and JavaScript. So this is the result of the build step. And from this, since everything is static, you will then be able to upload this to the CDN. So this is what this whole process is using static site generator.
Yeah. So it sort of, again, bypasses that whole need to have logic sort of on the server side. Like it's pre-generated and you've run all the logic once, but you're just getting the content to the browser as fast as possible.
Exactly. Yeah, so let's do a little bit of recap. So this is sort of like we already get to this point, let's say 10, 15 years ago. Yeah. And everything is just, HTML, CSS, and JavaScript. So let's do a quick recap. So this is this model is traditional server-side rendering. Every time you make a request to the server to one of the websites hosted like this, it will fetch the data from the database, run it through a template engine, generate like the HTML and CSS and JavaScript, and then send that back to the browser. So think WordPress, that sort of things. And then if you just have a simple static website, you can upload that to the CDN and all is good. So it's going to be like super fast, less latency. And yeah, and if you have like a limited number of pages of content, you can use a static site generator to build all of the static content and then upload to the CDN. So from here, people started, to do more complex stuff on the web. So they started doing application type thing, and I'm just gonna go past the whole like Flash era and go straight to like single page application. So let's go back to what's a website. So a website is basically just HTML and JavaScript and CSS, right? So this is traditionally what a website does, like what makeup of the website. Imagine with a single page application, what it actually does is it kind of take away like the HTML part. So instead of giving the client the HTML, it will actually just give it like it still give it an HTML, but it just give it like, imagine a shell. So think of it like a HTML with one div, and that's it. And then after the browser receives the HTML and JavaScript and CSS like this, it will parse the JavaScript. So the JavaScript here is the key, right? So after parse, JavaScript will kick in and take over the div. And then you can then use JavaScript to render your whole website. So this is sort of what single page application. So imagine client side React application, client side Vue, Angular, Svelte, like they all kind of work the same way in this kind of model. And so basically you just kind of letting the JavaScript or letting the framework have control of your HTML. And from here, the reason why it says it's single page application is imagine you have, let's say you have a portfolio of like a slash, index, right? Like this is your index.html. Let's say you have a slash about and slash contact. So in the traditional model. Each page like this will have their own HTML, CSS, JavaScript, and every time you go from like one URL to another URL, it will then go to the internet again and try to download that HTML, JavaScript and CSS. With this, you basically just sort of have one. This is like the only HTML you have. Like this is your only page. So that's why it's called single page. And there are like client-side technology that kind of take over the routing, so that every time you go from slash to about or to contact, it can detect that, and then you can use JavaScript to kind of render different things to behave differently according to the URL. But you are not actually making a request to like the server or to the CDN or anything like that.
Right. So all that logic is handled by the front end in your browser, basically.
Yes, exactly. With JavaScript.
Yeah.
And that technique is really good to build like an application, and like, so for example, if you have like an admin portal type thing, like that's why a lot of like SaaS or B2B SaaS company, they started using this technology to build their application part. So imagine thinking, let's say they keep their so let's say after the user sign in, they will receive this one HTML, JavaScript, and CSS, and because everything is in JavaScript, so like performance wise, it may be a little bit slower in the beginning to download all of the JavaScript, but once all the JavaScript is downloaded, it's super snappy to move from one page to another because all of the content is already there in the JavaScript bundle. But the issue with this approach is that it's not very SEO friendly. So you kind of have to pay the price because you have to send like all of the JavaScript right away in the beginning, and also because you rely on JavaScript to render the page, and the Google crawler is not a big fan of that. So it kind of penalizes you for doing it this way.
So if you're getting penalized in terms of SEO for this approach, are there any use cases that you could recommend this approach for regardless?
Yeah, so like at this point, the only time I would say you go with this is when you build a project that doesn't need SEO at all.
Right. So perhaps like let's say you have a service, and then you've got your sort of marketing website separate to that. Like the marketing website wouldn't use this, but then your service, like you've logged in and the user is interacting with your service. You could use this sort of approach here.
Yeah, exactly. So imagine you would use like WordPress or like a static page on your website. So you have like, and then actually a good example is Crystallize, right? Like with Crystallize, we have our static landing page here. However, the application part, when you want to sign in with the PIM, we have a different subdomain. So it's a different website. And this is a client-side React application. And we do that because, we can't use that technology on our marketing page because it's not SEO friendly.
Exactly. But for that PIM subdomain, we don't worry about the SEO side of things.
Exactly. Yeah, so it does that, it take care of like the application side really well. But it comes with the trade-off of SEO and initial page load speed.
Yeah.
So from then, like an evolution of this is developers they like working in this kind of framework. It's better than hand rolling their JavaScript, hand rolling their using jQuery and that sort of things. So they try to come up with a way to make this kind of model work with SEO. And yeah, so there are oh, and by the way, just a quick note. The earlier when I said, you would deliver like an HTML shell, like application shell, and then JavaScript will kick in and take over. Just a quick technical term. The technical term for that whole process is called hydration. So you deliver your HTML, and then JavaScript will then hydrate and then take control of your DOM. So basically, people want to continue using React, but they still want to have good SEO. So the solution for this that a lot of people come up with is something is basically their logic would be for they try to make this work with a static site generator. So yeah, let's talk about Gatsby for a second. So that's basically the premise of Gatsby is it will do this step where every time you want to build your website, you will fetch data from a database or your data source, and then it will loop through each content and then build in HTML, JavaScript, and CSS page. Okay, so let me try copy and paste this. So this is exactly the same. How here, so this is what it does, and then it will produce this. However, not only it produce just basic HTML and just CSS and JavaScript here, what it will also do is it will include in the JavaScript React or or Vue or Angular or whatever technologies you want to use. So from here, what happened is you will when a user visits this website, it would still see the actual HTML content, but after the first time it loads, React would then kick in, like React would then hydrate and kind of take over and take control of the browsing and all that stuff. So that's what in the article, that's what I mentioned, and I call it client. I think it's pre-rendering, like client side with pre-rendering.
Yeah.
Yeah, so this is how you can merge the static site generation with React application. However, after this, people start kind of running into a problem with where what if you have too many pages that you cannot use the static site to generate, or you have dynamic content that cannot be generated at real time. So usually in my head, a really good kind of example of an edge case for this is a forum. So imagine you maintain a forum where people, like your user, will be able to go in and generate a thread, right? And then from the thread, people can then like comment and stuff like that. So it's just a basic forum, and you want every single forum page to be good, with SEO. Or for example, if you think about it, Stack Overflow is the perfect example, right? You definitely want it, like every single question, you want it to be SEO friendly. You want Google to index them so that other people can then find that question. But you cannot apply this strategy because there are just hundreds of thousands of questions, and you simply unable to statically render them all.
Yeah, you can't generate a page or pages and pages and pages on the fly as well. Like, it's just too much.
Exactly. So that's when, the folks, this whole model kind of come back in. So server side rendering kind of come back in style, right? So the model is you have a server, you fetch data from the database, you run the data through the template engine. And in this case, if we're talking Next.js, it will use React as template engine. So React is your template engine to create HTML and CSS and JavaScript, and also React. And then you will deliver the HTML, CSS, and JavaScript to the browser. And then after the first load, that's kind of satisfy Google. Then React will then kick in and kind of take over if you have like interaction within the site. And then depending on how you configure Next.js, when you visit like another page, it may do like this whole flow again, needing to fetch the data from the database and render the HTML, CSS, and JavaScript. So so that's like server-side rendering with client rehydration. So that's kind of the term. It's getting kind of long, but that's kind of the mental model for this. And the reason people like to use this is people want the reactivity of React. People want to write React on the front end, but they need the SEO requirements of a server rendered application. And just before we move on, I want to mention that this is kind of the state of Gatsby and Next.js, I'd say 2-3 years ago. So Gatsby would lean more towards static side generation, and Next.js would lean more towards server side rendering. But then Gatsby kind of learned that from Next, and give, like, nowadays Gatsby 4, they give us server side rendering as well. And then Next also learned the static side part from Gatsby, and then they also give us static side generation. So now functionality wise, the two are quite similar, like they kind of collide in terms of like feature set. So nowadays you can do static generation with both Next and Gatsby, and you can do server side rendering with both Next and Gatsby.
Nice. That sounds like a good set of options for both of them then. But just before we move on, in regards to this more modern form of server-side rendering with reactivity, as you put it, what would you say are some of the drawbacks of that approach?
Yeah, exactly. That's a great question. I was about to move on to that part. So the drawback. So the pros of this. Let's just say, we kind of explain why people do this. The pros of this is you get the interactivity of React, but you still get the SEO performance of a server rendered application. So you kind of get the best of both worlds. So what you're doing is you merge server side rendering and client side application, like single page application together. So you get the best of both worlds, with those two technologies. But what you also get is the worst of both. So you basically you basically tie yourself down to a server again. So now there is a server again. Every time you cannot set this up on the CDN. Every time you visit a website that handle this, you using server side rendering with React, there is a server component. So you have to go to that server before you know, do like the DNS result back to you.
Right.
And also you have like the complexity of React and the bundle size of a single page application, because you have to then deliver React, which by itself is about 100 kilobytes. So, or maybe not 100 nowadays. I think maybe more like 60, 70 kilobytes.
Right.
So
So not so good for that sort of first page load, but perhaps once you've cached it, like you've already visited the site and you've got some of this content at least in cache, then it's not so bad. But that sort of first
exactly,
load can be quite take a toll.
exactly, exactly. Um, and then I just also want to mention a little bit about, I said we discussed earlier that the static site generation is not good enough for something like Stack Overflow, right? Because there's too many pages. Well, both Gatsby and Next.js have their own kind of like optimization for this. So the Next.js folks call it ISR. I don't remember what that stood for. Isomorphic. Oh, incremental static regeneration. Which is an optimization on top of like static generation. And then Gatsby have like DSR, which is defer defer static generation. And they both kind of quite similar in theory, where, for example, you can potentially just say during static generation, I only want to generate 100 most popular questions or 100 most popular threads. And then every time you visit a page that is not in the cache, that is not already statically generated, then Gatsby or Next.js will then generate it and then cache it, so that the next person, if they visit that page, it will already exist. But the first person visiting that page will have to wait for a little bit before that page can be built. So there are some technique to optimize this sort of flow, but I would say it's still relatively new. Like honestly, personally, I haven't had like firsthand experience with those kind of technique yet. But there are kind of optimization technique that people can do to solve this sort of problems.
Nice. Yeah. Sounds like a
Um,
good, maybe not a solution for all cases, but for a good number of them, it might help a lot.
okay, yeah, totally. And yeah, so let's do a quick recap on all of the different like types of rendering we have so far, right? So let's say we have okay, so we have so let's just say we have static content. So this is just HTML and JavaScript, CSS and JavaScript page, right? We have server-side rendering. We have static site generation. We have single page application. So I would say these are kind of like the building blocks, right? And then you can merge single SSR and SPR together. So SSR and SPR and SPA together to have like server-side rendering with client rehydration.
Yeah.
Or you can merge single site generation with single page application with client side pre-rendering, right? So these are this I would say this is the spectrum of this is kind of like the spectrum of all of these technologies, right? So if I want to maybe put a couple like technologies in place to see what's the model for those. So like if you just have a basic, let's just say you have a basic HTML, CSS, and JavaScript, then it's clearly just static content, right? But then if you have, let's just say WordPress, WordPress would then fall in single side, server side rendering.
Yeah.
If you have a React application or Vue or Svelte or Angular, we don't talk about Angular here, then it's a single page application. But then it gets a little bit murkier when we get to something like Next.js or Gatsby or Nuxt, which is the Vue version of Next. So when it comes to this sort of technology, it kind of go like the full spectrum here. So it would be both this and this. And then I kind of miss the static side generation part. Okay, so the static side, purely static side would be, something like Jekyll or Hugo or 11t, right? That would fall under static side generation.
Nice. Yeah.
Yeah. So this is kind of how they kind of different technologies play with each other. So a new technologies that I'm pretty excited about comes out recently, and it's a Remix, which is like another web framework on top of React. So with Remix, it has some time to learn from the lesson of Next.js and Gatsby. And what they ultimately decided to do is, instead of doing this, like server-side rendering with SPA or static side generation with SPA, what they go with is a server-side rendering with SPA, or you have an option to just go full-on server-side rendering. So you can just remove the whole SPA out of the picture, so no rehydration. And that got really exciting because you can then cut down the whole 70 kilobyte of React or any JavaScript you need if your page is simple enough. So imagine if you have like a landing page, Crystallize.com. You don't need a lot of like JavaScript in there. It's not an application. You don't make API requests. You just want content. Yeah. Then you can say, for this page, I purely just want server-side rendering. But then if there's a page that you need interaction, then you say, okay, I want the React part, the dynamic part of a single page application on this page as well.
Right. So kind of mix the two depending on which page you're on and the requirements for each page.
Yes, exactly. Yeah, so this is Remix, which is part of like a demo that we're gonna talk about in a little bit. Any thoughts about like this kind of chart, this whole table before we move on? I do have one note I want to maybe mention before we move on to the demo.
I think that's a great summary that you've shared here as well. And I think you've also put this same table or something very similar into the blog post that you've written as well. And that's in the description for anyone to do some further reading on, and they can see more details on that as well.
Mm-hmm. Totally. So before I move on, I want to move back to this. I remembered you asked me earlier, what's the drawback, right?
Yeah.
And I said that the drawback is you have a server now. And that is true. You have a server, but technology has come a long way since 2005, way back when most people use server-side rendering. Since then, like the cloud became a thing, right? And now there's a new kind of wave of way that people do things is basically on the cloud and particularly on the edge. And what that means is you will, instead of having one physical server, you will then go like the CDN model where you have a bunch of server all over the world. So this is the CDN model where you have a bunch of server, but these server only serve static content, right? So this is the CDN. Well, with technologies like Cloudflare workers, you can now have a similar version of a CDN where each server is a full-fledged server that can handle, JavaScript and logic, and it can then talk to the database by itself, so that you can put, so that you can optimize for server-side rendering. So imagine the drawback of server-side rendering is every time you make a request, it has to come all the way to the server. And then the server will then have to send back, we will then talk back to the browser, right? So this is browser to server need to be physically somewhere, and then it send back to browser. Now, what if the server is everywhere? Then the browser, just go to the closest location of the server, and that would be good, right? That would be all.
Exactly. Yeah. It cuts out a lot of that latency again.
Exactly. So it got really exciting. However, I do feel like it's still quite relatively early because we haven't solved this part, because it still have this part.
Yeah.
If you put all of your server on like everywhere, but if you have a centralized database in one single location, then it's kind of a moot point, because instead of, imagine the old way is you deploy your server and then your database in the same data center or on the same computer. Then you in no way talk to a server in California. That server will then talk to another server in California for the data and then talk back.
Yeah.
Instead, you can potentially from Norway talk to a computer in Norway, and then that computer in Norway have to talk to the database in California.
Yeah.
That basically you still have to make the same kind of distance, and it can potentially get worse if if the server and the database part needs to talk like multiple times. What if one database query is not enough? What if you need to make 5 different database calls? Then you actually want this server to be next to your database instead of next to your customer.
Exactly. For example, if you have to sequentially fetch some data and then based off the database response fetch something else, then yeah, it definitely sounds like it could be a lot slower. And I guess there is something about having both the server and the database on the same network locally as well that would increase speed too. Whereas in this sort of flow where you've got your local machine that you're requesting from, then the server on one network, then the database on another network, it adds in a bit more complexity in that sort of infrastructure perhaps too.
Yeah, exactly. So there have been a lot of like initiative of people moving the database to the edge as well. Because if the database is also at the edge and you deploy your server at the edge, then you're good. Then it's everywhere. And there are a couple, technologies that accomplish that. Like FaunaDB is actually one of the first one, or one of the earlier one. I know AWS. I think AWS, like DynamoDB is at the edge, but don't put me on that. I may be wrong. I know it's serverless, but I'm not sure if it's at the edge. So there's ways, like there are ways for people, like people are trying to solve this problem. And then another potential consideration is if your workload is read heavy, then maybe you can still do this where you have like your primary database in one location, but then you deploy the read replica globally. So every time you read, it will read to one of the read replica closest to it. But only write requests have to go all the way to the centralized database location. So that is also another technique that a lot of people use to solve for like a read heavy workload. But yeah, that's like my last point.
Yeah, I guess
Uh,
one other alternative, not so much a complex database per se, but key-value storage, for example. I think Cloudflare has their own KV storage system as well that's distributed that in that same sort of manner. I mean, it's not
yeah,
probably not the same as like a big sort of database that you'd use for complex data, but for um, small sets.
yeah, totally. One thing to note though is Cloudflare KV database. It is actually optimized for read heavy workload as well. So like a write will take up to 1 minute to propagate across all data center.
Right. Yeah.
So
There's some
so
delay,
keep,
perhaps.
mm,
Yeah.
so one of the technologies that I'm actually pretty excited is I don't think it's Unsplash. Upstash. One of the technologies that I'm actually really excited about is Upstash, where it's do serverless Redis with global read replicas, which is what we talk about. But the write is actually a lot faster than Cloudflare KV store. So I think it can promise like read to be uh, sub 100 millisecond read, and for write it will be like 300 or 400 millisecond write.
Nice.
So it's actually really interesting. I've been itching to play around with that.
Yeah, definitely. It sounds like a cool, I mean, upcoming sort of thing, perhaps. So, yeah.
Yeah, but that's like there's a lot more exploration in this kind of realm of like globally distributed edge computing type thing, and it's getting very very interesting.
Right.
Yeah, but yeah, that's all I have in terms of like conceptual ideas. Just noticed
Nice.
it
Yeah.
took 50 minutes for us to get here, so
Yeah.
apologize for the rambling.
I think it's been very informative to go through this whole, like, to see how not just things are now, but how it sort of evolved and why, like the reasons behind these changes, the reasons, the drawbacks of previous approaches, of the evolving approaches as well, and even the approaches that we have now, to see how they sort of compare against each other, and when you'd use one over the other. But
Yeah,
I do see that you have a couple of demos there as well.
yeah,
Regarding
totally.
Drawbacks and Next. And
Yeah, so let's start with the Create React app, which is like a single page application with React. So this is a small application that I built. Um, so I just have a store on Crystallize with like 3 products: a watch, a hat, and a T-shirt. So you can so on load, it fetch some data from Crystallize. You can click on watch, you go to /watch and watch, and this content is from Crystallize, and I probably should show that soon. So it's basically this. Nothing too fancy. So this is kind of how it works with Create React app. So this is like the demo for the Create React app. And what I want to showcase with Create React app here is if you pull up Postman and you make a GET request to this domain, you can actually see what it sends back. And here, like this is the HTML that it sends back. So it's very bare bone. It gives you one div with ID root. So how does this, it turns into this, right? So what happened is after you send this, it will render root, and then JavaScript will then kick in and then take over and then render all of this. So that's what I meant by single page application only, giving you like the app shell, application shell. And this is not good for SEO.
yeah.
So the next example I have with Next.js is I actually built the same thing, but in two different versions. I built a static version where it used this, static side generation flow. And then I built a dynamic version where it's do the server side rendering flow. So with static, what happens is whenever, so when I run like the build command, when I deploy to Vercel, it will then fetch all of my product page. So it did this hours ago to build these pages, and now it's just HTML and JavaScript and CSS. Whereas with dynamic, every time I visit this page, it will fetch something new, or it will try to refetch the data again. So it needs to talk to Crystallize again every time I go to dynamic. So just gonna give you a quick demo here. So let's say it's static. It's very snappy, right? Like it's super quick, super fast to move around. And you can see like here, like this is the Create React app version. You see there's like some loading state. And then if I go here, like you can see there's a little bit of like a loading version because it has to fetch data before it send, here to the browser.
Yeah, and that definitely sort of has the pros and cons, I guess, depending on the use case of, in this sort of example of a store, for example, if you have a very small sort of store that's, let's say you're an artist or a photographer and you're sort of selling your like digital artwork or something that doesn't need to be updated in terms of stock or prices too often because it's quite a small sort of store, you could use that static sort of approach where you've generated these things with a preset listing of prices and products. But then if you have a larger sort of store that is constantly, I don't know, you're selling computer products and the stock is constantly going up and down, you've got sales that are happening all the time and changing, and prices are changing, stocks changing, then perhaps this more dynamic approach is better suited to you because you're always fetching that latest data.
Yeah, exactly. Yeah, but you can just a small example just to show static can be really awesome. Like it's super fast. So moving to dynamic. So when I click this, it actually will need to fetch the data from. So it will actually, what happened is when I click this, it will go to a serverless function in Washington, DC. And then from that, inside that serverless function, it will then fetch the data from Crystallize before it get back to me. So there's going to be like a little bit of latency before it actually comes back.
Right.
Yeah, so I click it. It takes me a little bit of time, right, to show this. And then now I'm going to say I click it, and then hopefully it takes long enough, to go to Washington to show like the delay. So I'm clicking it now. Now it turns, right? So there's like a half a second, 1 second type of delay. So like I'm constantly moving here, and it's not as quick as the static version where everything just flew. So this is like the dynamic version with Next. And if you have time, if you want to play more around with us, you can use like a VPN to change your location. So like I'm saying, the dynamic part is a serverless function in Washington. So you can change your VPN to somewhere in Washington, and it's going to be like super fast. But if you change the VPN to Norway, or change the VPN to like India, Japan, or whatever, then and then you try to visit this, then you can start seeing like the speed difference. And like what I meant by server side rendering can be a lot slower than like static content and stuff like that.
Right. Yeah.
Yeah. And then lastly, I want to show the remix version. As for the remix version, instead, because it only have two mode, it doesn't have static, but instead it has two mode. It has the mode with script or with no script. So what I mean is no script is purely server side rendering, And with the script is server-side rendering with client rehydration. So with the React part kicking in. So the demo is not gonna make sense because it's gonna be like very similar. It's gonna look exactly the same. Browsing through, maybe you can, I don't know if you can feel it at all, but the no script is a little bit faster. But I assume it's hard for you to kind of gauge that with, me being the one who click and veer like the stream and stuff. But what I want to show is the bundle size. What happened when the browser make a request? So I'm opening, an incognito page, and I'm opening the network tab, and I'm visiting the no script version. Well, let's see. I'm gonna go visit the script version first. All right. So you can see here it transfers 73.7 kilobytes with this. So let's say if we go to like the Next.js version for, let's say, dynamic. It transfer 92 kilobytes. So the difference is a little bit, 20 kilobytes difference. But let's say if we go to the no script version, it transfer 974 bytes. So less than 1 kilobyte versus 70 kilobytes. So that's the speed difference, and that's like the bundle size difference, because we're not sending any JavaScript at all from the no script version. So that's why it's that's the part that's really exciting with Remix. And then I want to quickly show, so this is the response when you go purely single page application with Postman. And this is what happens when you go purely server-side rendering. So you can see like the div tag and like all the contents is here. And then the only script tag you see is like a small script from Remix that helps with accessibility, and that helps keep your scroll position or something like that. But other than that, there is zero JavaScript anywhere on the HTML. Like, it's not in head, it's not in body. This is the only script tag in here.
Okay, yeah. So you can definitely see how that sort of minifies the size that you're getting back of the data, which is great.
Exactly. And if you go to like the script version, like this is where it ends, right? Like earlier it ended at this, and now there's a couple of link tag to like the JavaScript bundle with my JavaScript code, like the layout and some React stuff. I bet one of the chunk here is React. So there are a lot more thing for the browser to load.
Yeah, definitely. And we do have a question in the stream as well. How does this transfer data size compare for Next.js, for example? Because we've seen the Remix ones here, but what about Next? Is it larger, or for the static Next one?
Okay. Yeah, we can. I think static Next versus non-static Next is the same. Like I would be surprised to see if there's any difference at all. Okay, so all of them are cache. So I'm gonna do a hard refresh to get a better idea of the bundle size. So it seems like it transfers 78.8. So it hover around 70 to 90. Like there's some caching. Clearly, there's some caching here. So I would say around 80 kilobyte, 90 kilobytes, something like that for the dynamic version.
Yeah.
If you go to the static version, it's cached. So I'm going to do a harsh refresh again. Same thing. So 80 kilobytes. So really the difference between a static and a dynamic Next.js is zero. Like there's no difference at all.
Right. Yeah.
Yeah, because like they kind of do the same thing. Like they ship the same router, they ship the same React, ship the same bundle. It's just like they ship the same HTML, CSS, JavaScript. Like everything is kind of exactly the same. The only difference is when that HTML and CSS and JavaScript was generated. And I have like a quick demo here. Like this is the biggest difference between static and dynamic here is, let's say static, let's say you go to the hat. This is a dope hat, right? I'm gonna go over to Crystallize and modify this content.
Yeah.
So here, this is a dope hat on the static version. If I go to the dynamic version and the hat, it's the same, right? So now here, I'm in the rendering demo tenant that I set up. I'm in the hat. So I'm gonna change the story to, this is a very cool hat, and publish. All right, so it's published now, so it's live. Now, if I refresh the dynamic page, it says this is a very cool hat. It shows up here right away.
Yeah.
So what that means is every time I refresh this, there's a serverless function that wait to to accept that request, and then it will then fetch crystallized data before it generate the HTML and JavaScript and CSS and send it to the browser. Right. Whereas on the static version, the hat is still the same because this HTML was generated 8 hours ago. So in order for this new content to be reflected, there have to be some sort of connection, like you have to trigger a redeployment somehow. Either you use Crystallize webhook to trigger a redeployment with Vercel, or you just decide to have a cron job deploy once a day, or you just deploy whenever you want to. So if you want, you can manually go to Vercel to click like redeploy. But with static, it's not gonna reflect like the latest updates.
Yeah. And again, I guess that sort of comes back to your store sort of use case as well, whether it's like a small store where you don't care about these instantaneous updates, or you need to reflect that data to the front end as soon as possible.
Exactly, yes. Yeah, and just quickly show with Remix, since everything is server-side rendering, so it got updated right away. And with React, it also got updated because it only makes the requests in the browser, like with an HTTP request from your browser, every time you load. So it also got updated. So the only thing that kind of lagged behind is static generation. Anything that involves static generation, static site generator, that sort of things, there is a build step that you have to kind of consider.
Yeah, definitely. And that sort of has its, I mean, that can be a pro and a con depending on the use case again.
Mm-hmm. Yeah, for sure. Right, it's a tool in the toolbox for you to decide whether you want to, use static generation or not. And I think you can get like really, really far with it. It's just something that you kind of have to understand and work around and make things work the way you want it to be to work, right?
Yeah. Exactly.
But yeah, that's basically what I have prepared.
Perfect. Then thank you very much for taking us through this really detailed and comprehensive history of the how we evolved to get to these current rendering methods that we use today. And sort of where you'd use each of them as well. And also, it's been really cool to see the demos with how they sort of compare together in this simple example, which is great. So and for anyone who's watching this, you can always get more details regarding this in the blog post that's linked in the description that was written by Alex as well. think this is a good place to end. And so thank you very much for joining, Alex, and thank you everyone for watching the stream. And yeah, we'll see you all next week with the next live stream. So thanks for watching and see you later.